Alright, so today's question is 173 binary search tree iterator. We are asked to implement the iterator over a binary search tree, and the iterator will be initialized with root node of the binary search tree. So we have been passing there is going to be a reference to a root node being passed in our constructor. After that initialization, the .next method from the object will return the next smallest number in the binary search tree. So it's since it's returning the next smallest number each time, it's essentially iterating over the tree in increasing order. That's since this tree is binary search tree, that's actually the in order traversal. We visit the left and node itself and try to go right. And when we land at this node, we try to go left. And once we exhausted the exploration to its left, we backtrack to the node itself. Once we put the node's value here, and we try to go to the right, and just repeat that process. So we're gonna put that traversal strategy logic into under the .next method, and we will have two variables to keep track of the node that we need to visit next, as well as a stack to keep track of the nodes that we need to backtrack to. So that's gonna be the strategy of solving this problem. As for time and space complexity, the time complexity is order of n, in order traversal order of n. The space is in the best case log n if the tree is perfectly balanced. If the tree is degraded into a singularly linked list, then it's order of n. So with that analysis, let's actually go into the actual coding here. So we're initializing the nodes that we need to visit with this root node, and we're initializing the stack to be empty. Can I turn off the hinting? No. I couldn't. Huh. So it seems that we also have to implement another function method called hasNext. You will return whether we still have nodes unvisited yet. So that's quite simple actually. You just return whether we have nodes we need to backtrack to visit, or we have another node that we need to visit. If either of this is true, meaning that we still have values to look at, nodes to look at, then this should be true. Otherwise, if none of this is if this is not empty and this is not a null pointer, then we still have nodes to look at. So as for the traversal strategy, it's while we still have node to look at, we'll try to go to as left as possible, because to the left is always going to lead us to the smaller value. So if we keep go left, we will definitely hit the current smallest value. So that's self.node, and we also need to remember the nodes that we need to go back to. So that's so we will push the nodes onto the stack before we go left. So that's moving to the left to grab the smaller values. Once we've done that, this will terminate when we reach leaf nodes. So this will evaluate to none, and at that time we can just pop out the top value. That will be guaranteed to be the leaf node. And this node's value is the one that we want to return. Val, right? Yeah. So if this node is a leaf node, once we grab the value, we will try to backtrack. But if this node is not a leaf node, but some node like 7, we will also want to, once we visit that node, we want to go right. So we'll have this here. And return this particular value here. So that's pretty much the code. Yeah, just standard iterative version of in-order traversal. We take the part of within the bigger while loop and just put it under here. That's pretty much it. Let me see if we have any problems. We initializing these two things. We have no nodes to backtrack to. We are currently the next node that we are exploring is this root node, and this checking looks right to me. This strategy looks good to me. So yeah, let's submit it. So it's working. It's kind of slow and it's taking more space. Just wondering why is that. The thing that I don't like this is that ideally because it's Python, ideally we were actually using something like Thunder next, and probably for the Leetcode's purpose, we just overload this, right? And this .next, when it's being first called, it will trigger this iter method. What it does is just initializing these two variables together, right? So let me actually remember this rule so that we can reuse the iterator object as many times as we want. The earlier version, the submit version, if we want to iterate over this binary search tree twice, we have to call this constructor twice. So that's not very nice. Let's have a private method reset, which is basically resetting these two states here. And for the we will always want to reset when we construct the object. And for the iterator method, we'll just we'll just call the reset and return self. So this would do. I think this would do. Let me move this under here actually, so that this looks good to me. So let's try to submit this version as well. It works as well. Slightly faster, but the percentage go up a lot. This is still the same thing for the memory usage. So I'm just wondering what kind of method would the other people use to reduce this. Just curious. Okay, so that's the question for today. Bye for now.